and welcome back to the video lecture series of learning theory of automata and formal languages. We are into unit number 1 and we are into lecture number 3. So, in the previous 2 lectures we have learned the introduction related to automata, introduction related to finite automata, introduction related to deterministic finite automata. We have come across different terminologies like alphabets, strings, then power of strings. Okay, then we have seen what is the meaning of a language. Now, we will be in a particular path to carry forward with the designing process. See, till now we have understood only the basic terminologies which you need to memorize or which you need to keep in stock right now, because right now when we will be starting off with the designing process, you will be required all those terminologies again and again. Okay. So, let us check it out what is the topic for today's agenda. So, today we will be looking into deterministic finite automata and their examples, concentrating only with the designing process today, okay, in this video. After that, in the next video also we will be concentrating only on the examples. So, first point is that before going into this construction question, my point of delivering is that first you need to understand, you need to do a practice over the construction part. Okay, construction part, and this construction is solely dependent on language to a DFA, language to a machine. See, being a human being, I will just try as a user or as a human being, I will just try to give you a language. Then the designer or then the coder will try to analyze particular concepts from that particular language, and then a machine will be designed, correct. So, for the construction purpose, we need to focus on two things. One is the language. Always remember that the language will be given to you, the language will be given to you, clear. From the language you need to identify the strings, which are nothing but what? Inputs. Okay. From the strings what we need to do? We need to analyze, and we need to put these strings into the machine format, that is the designing part. And this machine can be what? This machine can be a finite automata, can be a Turing machine. Okay. We will be looking into the hierarchy properly in the upcoming lectures, but right now we are concentrating on the preliminary machine, that is your finite automata, that is your DFA, deterministic finite automata. So, if students, if you have like missed the first 2 video lecture, I would like that please go through the first 2 video lectures, otherwise you will not be able to understand this construction part. Okay. Now, let us check it out how to construct this. So, first example is given to, this is the basic example for starting up with the designing process. The first question given to you is that construct a DFA, that is you need to construct a deterministic finite automata over the input alphabets A and B, where the length is equals to 2, So, my dear students, this length is equals to 2 is nothing but the language given to you. This is the language given to you in the form of what? The length is equals to 2, exactly 2 over the input alphabets A and B, correct. Now, let us check how to proceed forward. First, we need to write down the language. Always remember, the language is given to you. First, you need to write the language in the form of strings. Okay. How to write down? Let me write down this language L is equals to in the set builder form. Okay. Now, let me erase all the things and I will carry forward with the in a proper way. Okay. I have already mentioned the language is length is equals to 2, and I have also given the final answer for this, but how did I got this? This should be remembered. Okay. See, language here input alphabets is given as A and B. How to find out the length equals to 2? See, first you need to find out that this is nothing but your epsilon, correct. This is nothing but your sigma, sorry, that is the input alphabets, correct. Now, I need to find out the length is equals to 2, that means I need to find out length is equals to 2, that means power of this alphabet. How to calculate? So, A and B, we need to concatenate these two things, A and B. Now, if we do an ordered pair process that we generally knows in mathematics, A, okay, I will not write like this, I will simply go in this particular format. Okay. I will go a concatenation process, that means I will write A okay, comma, next I will do A, then B, correct. So, A B, then I will do B A, then I will write B A, and then finally, I will do B B B B. This is your length is equals to 2. Now, if you look into this particular final output strings and looking into the language, language says that length is equals to 2, that means exactly 2. If you count this, the number of alphabets in the particular strings, 2, all 2. So, therefore, length is equals to what? Length is equals to 2. So, this is how you need to find out. If you need to find out length is equals to 3, then here it will be A, B, 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 A, B, A, B, A, B, correct, A, B, 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 A, like this. So, if you need to find out length, you just need to find out the total number of appearing alphabets in a particular string. That is the way. Okay. So, therefore, finally, what we can conclude is that we can conclude that our language is this one. Now, how to design the automata? The automata will be designed in this process, that this automata will try to scan all the strings one by one and try to accept those strings. That is how you need to design the machine, got it? It is not that it will be accepting all the strings together, no, it will be accepting the strings one by one. So, that means finally, I have to design the automata in such a way that first it will check for A whether it is accepted or not, yes, then it will check for A B, then it will check for B A, then it will check for B B, then finally we can say that this is the final automata. So, let us check it out the graphical flow of the diagram. So, it will look like that. First of all, I will be starting off with the first state, that is your A, clear, initial state, okay. A is the initial state, then I will take one more state as B, because I need to carry forward the flow. First what it will check? It will check first A. So, therefore, I will do a transition for A, okay. So, this is the transition I have given. Now, I will put the input alphabet A. So, A has been scanned, right. Now, for the next A, it will not be in the same transition, it will go from state B to another state. So, how the transition will look like? One more transition, it will go to another state, that is for A, and it will go to one more state, that is your C. Now, we can say that this A has been accepted. Why? Because this particular C is nothing but what? Final state. I have already mentioned in the previous video that how to represent a final state. So, we got the final state. Now, we can move to the next alphabet. So, that means next string. So, that means this string is accepted A. Now, we will be looking into A B. Now, if you look into A B, already A is present in the initial state. So, nothing, no more, it is not required to again draw the transition for A. Now, we will move back to what? Transition number B. Okay. So, that means how the diagram will look like? The diagram will look like this one. Now, B will be coming over here, clear. So, if you look into the particular process, A from state A to state B, A transition, then from state B to capital letter state C, that is the final state, we got the input string A B. So, that means these two strings are accepted. Now, you can pause the video and you can think of the next string, that is B A. See, B, for B there is no initial transition from the initial state. So, I need to put a transition for B as well, got it. So, I got a transition for B, okay. Already for A there is a transition. So, that means B A, and it is reaching the final state. So, this string is also accepted. Now, coming to the last one, that is B B. B is coming from the initial state, yes. Then next B, is there any B? Yes. So, finally, we got B B is also accepted. So, therefore, we are done with the scenario right now, and we have got all the strings being accepted. Finish. First thing what you need to do is that write down the language, okay. Write down all possible types of strings. See, if it is an infinite, it is not possible to write down the entire strings. What you need to do? You need to find out some of the strings through which you can analyze that yes, the machine will be accepting all the strings, correct. But in this case, it is a finite language. It is length equals to 2. So, only these 4 strings are available. So, I have first write down the language in this form of strings. Second thing what you need to do? Try to accept all the strings, okay. And finally, in the third step what you need to do? You need to maintain the DFA restrictions. DFA has a restrictions also. DFA, what it says, that for every input symbol there should be exactly one transition, not more than that, not less than that. Now, if you look into the input alphabets, what are the input alphabets? One is A, another one is B. So, DFA needs to check for all the input symbols exactly one transitions, not more than that, okay? And for every states, you need to remember for every states, clear. Now, let us come with the state A. From state A, there is an input transition for A and there is an input transition for B also. So, that means state A is accepting the DFA restriction, clear. Now, let us go with the state B. From state B, you can check there is a transition, there is a B transition also. Although it is a single transition, it means that there is an, this means what? This means like this, state A is there and state B is there, one A transition and another one is a B transition. So, we can write like this also, there is a comma, you should give a comma in between them, I have not given. So, you should give a comma, this will separate A transition and B transition, clear. Now, if you look into state B also, state B is also accepting the DFA restriction. Now, if you come across with state C, state C is not accepting the DFA restriction. Why? Because from state C there is no transition for A and B. What DFA says, that for all the input symbols there should be exactly one transition, not more than that, not less than that, correct. So, there should be a transition, but if I give a transition from here, it will affect this particular language, because the language is already been accepted. Now, what I am doing? I am trying to work on the DFA restrictions, correct. So, what I will do? I will, if in such a case that where the language has been satisfied and now you are trying to satisfy the DFA restrictions, you can use one more state which is known as a dead state. Why? I will show you. I will use one more transition and it will go to a state, say D. Okay, now, you can see from state C, A and B is coming. So, it is accepting the DFA restriction, but this state D, why I am telling it is a dead state? Because here I will try to take a self loop and I will put a transition for A and B. Okay. Now, I have done for state D. See why I have done this one, because for state C it is accepted, these are all accepting now, because all are having 1 transitions in between them, correct. But for state D, if I do not give a self loop, it will be not accepting the DFA restrictions, because DFA says that for every input symbol there should be exactly one transition. So, if I give a transition from D to backtrack to other states, then again the language will keep on increasing, which we can't do. And I have also mentioned that this D is nothing but a dead state. Okay, sorry, you will not be able to see this. A dead state. Why? A state is said to be a dead state when from that particular state there will be a transitions, but those transitions are not going to a final state. Then you can think of logically that whether these strings, wherever it is coming out from D, is it going to a final state? There is no transitions, it is going to final state. Which is the final state? Final state is this one, correct. But in to the final state there is no transition from D. So, that means whatever it will come on to the loop of this particular transition only in D, and it will not be accepted. So, that is why I have said that this D is a nothing but a dead state, or in some books it is also mentioned as trap state. So, this is all about your final concept. Now, if you can look into this diagram is properly been elaborated. First, we have accepted the language, and then we have accepted the restrictions for DFA, for which I have utilized a dead state, that is D. I have not mentioned this A and B. Okay. So, this is how you need to design a particular DFA. I hope it is clear to you all. So, this is only a single example. Now, we will be going with multiple examples. Okay. Now, let us go with the next slide, next example. This says that where the length is at most 2, length is at most 2. At most means what? Maximum to maximum length should be 2. So, that means length will how much? The language will comprise of length 0, 1 and 2. So, you can pause the video, you can think of it, will it be more than 2? No, because it is saying that at most 2, got it. So, that means if we say length is equals to 2, so this is not a language, okay. This is length, okay. Length is equals to 0. If I say length equals to 0, that means it will come epsilon. I have already mentioned in the previous video. If length equals to 1, then it will be A and single B, number of elements in the string only 1 1. If length equals to 2, just now we have done in the previous example, AA, AB, BA, BB. So, got it. So, therefore, will there be any more strings? No, till now we have satisfied. So, this is for length 0, this is for length 1 and this is for length 2. So, 0, 1 and 2. So, I hope you got the string now, you got the language right now in the form of a string. So, which I have already mentioned over here. So, I am erasing this thing. So, you got the language, now you need to design a particular DFA. So, let us check it out the flow. First we will take the initial state. Okay. Now, why I have taken this A as an initial state as a final state also? See, there can be an initial state and a final state. Always remember that in the construction process of DFA or NFA or whatever machines you are going to do, there will be exactly one initial state, but there can be multiple final states. Got it? So, why I have taken A as the initial state as well as the final state? Why? Because the first string is length equals to 0, that means no input strings. So, therefore, I have to take the initial as a final. Got it? Next comes single A, single B. So, you can pause the video how to do it. Single A, that means I will be designing a single A transition and I will take one more state and I have to make the second state also as a final state. Then for B, what I have to do? Comma B, correct? So, this is what I have to do. Now, let me check the flow. A, I got it, then B, got it. Clear? So, I got epsilon, I got A, I got B. Now, for AA, AB, BA, BB already you have done in the previous example. So, what I have to do? I have to take one more state and that state is already a final state, correct? So, what I have to do? The transition will be state C, got it? So, this is how you got A and BA, clear? Now, till here you can see all these strings are accepted. Now, you can pause the video and rethink of it. What we have to do now? We have to now validate the restrictions of DFA. How to validate the restrictions of DFA? From we have to check one by one every state. State A is satisfying because both the input symbols having 1 transition exactly. State B is also accepting because for both the input symbols there is 1 input transitions. State C is not accepting. For that purpose, what we have to do? Now, already the language is accepted. We have to now introduce a new more state that is known as your date state. How to do this? I have taken a date state. I have taken a transition. For in that transition, I will be taking A and I will taking B. Okay. And then what I will do? I will take a self loop of A and B over D. So, now you can look into this diagram. For every state there are transitions for A and B, and till here the language is already been accepted. This part I have introduced only for the restrictions part in the case of DFA. Now, if you have learned, if you have gone through my first video lecture, then I have already told you, sorry, second video lecture, I have already told you about the DFA and NFA difference. Only DFA has the restriction, NFA does not have any restriction. So, I am just adding one more point with this particular context. Why? Till here the language is accepted, correct? I am done with the language, all the strings are accepted. This particular diagram is called as NFA, because I do not require any kind of restrictions in NFA. NFA just needs to focus that whether the string has been accepted or not, or whether the language has been accepted or not. So, that means till here it is an NFA, and overall if you look into the diagram, this is a DFA, clear? So, this is all about the second question. Now, let us go with the third question. Third question says that you need to construct a DFA over the same alphabet strings where the length is at least 2. At least 2 means minimum I need 2 length, after that you can take n number. So, that means this is not an finite language, this is an infinite language. Later on we will come across with one more point, that whether DFA, NFA, epsilon NFA, these accepts infinite language or not. Okay. Why there are certain problems with the infinite language, I will discuss with you all once we are done with the entire unit. Okay. So, this is an infinite language. I hope till here it is clear to you all. This is nothing but length is equals to 2. Now, if you count these 3 alphabets in the string, so that means you can pause the video and you can think of it, these are length equals to 4, correct. So, if you look into these strings, these are nothing but length equals to 3. Okay. Now, if you come across with one more string, then it will be A, B, 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 A, B, A, B, BA like this. This will be length equals to 4, then length equals to 5 will be there, length equals to 6, it will keep on going until infinite. Got it? So, that means what I have to do, I have to now design the diagram for it. I know length equals to 2 diagram. So, what I will do a little bit fast. I will take state A, I will take state B, I will take state C. Okay. Now, here I have drawn A and B, here I have drawn A and B, and this is your final state. So, till here we have got length is equals to 2, correct. I do not have any restrictions after that. I can take n number of lengths, right, because it is at least 2 I have drawn. I do not have any restriction. What I can do? I do not have to take in a self loop, and I can take A and B as a transition. Now, what this mean is that till here it is A. Suppose I need to find out 5 times A. Okay. So, first A, second A I will be getting from here only. Okay. From these 3 A's I will be taking from the self loop. So, this self loop I think you are well known with the loop concept, that it will keep on going in a circular context, correct. So, if I have to find out, suppose A, B, as simple as that, A reached state C, after that B. So, one time B, then A, then B. So, with this concept I can assure you that this entire language will be accepted. Got it? So, this is all about the third question, that is where the length is at least 2. At least means minimum 2, more than that it can accept any strings, correct. So, that is why I have drawn first half for length is equals to 2. After that there is no restriction. So, I took a self loop. Now, if you look into the entire diagram, for all the states now DFA is accepting. See, you might be thinking that yes, from state C this is a self loop, right. So, self loop can be multiple times, then where the DFA concepts arise, where the DFA restrictions arises. Yes, DFA says that for every input string there should be exactly one transition is coming out. Do not look with the self loop concept that multiple transitions are going on. No, DFA says that for every input symbol there should be exactly one transition which can go to another state or which can go to itself. Clear? So, this is about the third question. Let us go with the fourth question. Fourth question says that where the length is even. Length is even means what? What are the languages elements? 0, 2, 4, 6, 8 like this, correct. So, I will give you a shortcut way of understanding this, so that it will be easy for you. Okay. Length is equals to even, that means what? The language will comprise of, first for 0 it will be epsilon, for length equals to 2 A, BA, BB, then AB, correct, and for length equals to 4 it will be A, BB, and it will keep on going. So, always try while doing a particular designing process, first you write down the language. If it is an infinite, try to write down 10 to 12 strings, so that it will be easy for you to analyze the diagram. See, what I will do for epsilon, I am sure that I know how to draw for epsilon. Initial state will be final state, correct. If I have to find out 2 times A, I will not use one more state. What I will do? I will take one transition for A and I will backtrack one more transition for A. Now, if I want to find out 6 times A, because 6 length is there. So, 6 times A, you can directly get it from here. See, 1A, 2A, 3A, 4A, 5A, 6A, where the 6th A is ending, it is ending in the final state only. So, this string will be accepted. Okay. Now, if I find out, if I have to go with the next string BA, so there is no transition from the initial state for B. What I will do? B comma A. So, B and A I am already having, so it will be accepted. If I have to find out B transition is there, from state B there is no transition for B. What I will do? Comma B. So, B. So, like this, if I have to find out 8 times B, 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8B, 8B is coming in the final state. So, this is the perfect diagram for getting all particular strings whose length is even, Okay. Let us go with the next question. Next question says where length is odd. So, this is an assignment for you. You can just think of it where the length is equals to odd. Length is equals to odd means you need to find out for 1, 3, 5, 7 like this. So, for 1 I already know that it will be like this a comma b, 1 I already know, right. So, if I have to find out 3 times, can I take a back loop, backtrack of it? See a 3 a you got it, 5 a 1 2 3 4 5 times you got it. So, this is just the diagram I have given you, this is the only diagram. Okay, now you can analyze this diagram and you can relate with the length part. Okay, so this is just a working part from your side. Finally, we can come across with the transition table part. So, transition table, this is what we have done, the transition diagram, this is what the transition diagram is all about. After this, we need to write down a transition table also. Okay. So, transition table, this is the theoretical part where we need to focus only on the few points: columns, rows. Columns correspond to the input symbols, rows correspond to the states, okay, and entries corresponds to the next state. That can be next state, that can be the similar state also. Okay, it depends. So, these are the theoretical part, but let me explain to you with this example. See, I have drawn this diagram, right. I have to take a transition table for this. Okay, I will divide this towards the columns. It has already mentioned, see, columns represents what? Input symbols, and rows corresponds to the states. So, what I will do? I will take A and B. So, these are the columns, and rows implies what? States. States are what? A and B. Now, you need to remember one more thing. That state, initial state is represented by this, and final state is represented by this. Okay. So, that means how I will now fill up the diagram. State A, on seeing input alphabet A, where it is going? It is going to state B. So, it will be state B. This is the way you need to fill up. State A, on seeing B, where it is going? B. State B, on seeing A, where it is going? State B, on seeing A, where it is on seeing B, where it is going? State A. So, therefore, this is the final transition table for your diagram. So, the remaining part, that is the example number 6 contains exactly one alphabet and multiples of 3, okay, and starts with 1 and ends with 0. Okay. So, these 3 concepts, these 4 examples we will be doing along with few more examples in the next video lectures. Okay. So, there we will be looking into few more questions, and I will try to relate with this, okay, and then we will sum up few of the cases which you need to focus for the construction of DFA as well as NFA. Okay. So, this is all about for today's lecture. This lecture we will be continuing with the next lecture. Thank you.